This is my Module 2 presentation on moderation and mediation in regression. So really, moderators and mediators are an expansion of the general linear model. So it allows us to go beyond main effects to understand more deeply about our data and the relationships that exist. So to start with explaining a little bit more about moderation, as we know, the omission of relevant variables will lead to biased parameter estimates. So a failure to include interaction terms is equivalent to omitting these relevant variables. And the general linear model includes these additive effects, and interaction terms are also additive because they're added to our primary predictors above and beyond our main effects, but they're also multiplicative. So this moderation equation would read y is a function of x1 or x2 or x1 and x2. So through including moderated effects, we are including all possible combinations of our main effects, which really exhausts our model. And so by looking at this moderation model, we can see that a moderator is really just a variable that influences the relationship of a predictor and an outcome variable. So the combined relationship of x and the moderator becomes an effect on y. So in this presentation, I'm going to go through 3 moderation models and see how we can utilize data construction to help us understand outcomes in moderated regression models. And as you can see here, I've listed this regression equation, which helps us to understand how in moderation, the parameter estimates will help us to use simple slopes and simple intercepts to visualize our moderated effects. So importantly here, B1 and B3 are parameters that will affect our slope, and B2 and B0 are parameters that will affect our intercept. So let's take a look at our first model. And in this first model, x1 is a continuous variable and x2 is our moderator and is a dichotomous variable. And importantly, this will be consistent throughout all 3 moderation models. So by looking first at just the main effects model, we can see that the direct effects for both x1 and x2 are significant. And then looking at the model that includes the interaction effect, we can see that the interaction term is significant at the 0.05 level, which reflects a significant contribution above and beyond the main effect. So we will reject the null hypothesis at the 0.05 level. And this is also important because when we include the interaction term, we can see by looking at the R squared that the amount of variance explained increases by 10% from 0.7 to about 0.8. And another important part to look at when we're comparing a main effects model to the model which includes our interaction term is our parameter estimate. So our parameter estimates are going to be contingent upon the predictors we include in our model because of partial correlations. And also this is especially important in moderation because we're going to have some multicollinearity with our interaction term and our main effects. And what we can do to help with that is center our variables. So in mean centering, our correlations will remain the same because we'll keep the variance associated with those variables, but we're able to help with multicollinearity by taking out metric differences. So this will make our parameters a little more interpretable. So let's look at the plot and a couple of things about simple slopes and simple intercepts. If we have a significant moderator, we'll have a significantly different slopes between our groups. So when our moderator equals 0 or when our moderator equals 1. And also, we can see a significant main effect for our moderator when there's a difference in intercept. So we can see both of those significant effects here. And this has to do with how I modeled the y variable. So I modeled B0 to be significantly different from 0, B1 to be non-significantly different from 0. So we can see that in the slope of when x2 is equal to 0. And then B2 to be significant and B3 to also be significant. So looking at the diagnostics for this model, we can see that we have relatively normally distributed residuals, they look independent residuals, and we have few influential outliers, so we can conclude that our diagnostics look pretty blue. So let's move on to our next moderation model to see how we can vary the significance of that moderated effect. So once again, we can see that we have 2 significant main effects, and we are explaining about 92% of the variance in the main effects model. However, we do not have a significant interaction term, so we fail to reject the null hypothesis at the 0.05 level, meaning that our interaction term does not predict above and beyond our main effects, and that x2 does not influence the relationship between x1 and y. And also, we can see by looking at R squared that we're not explaining any more of the variance in y by including the moderation effect. But we can see that both of our parameters remain significant when testing the interaction. So let's look at our plot and see if we predicted what our outcome would be. So again, we're looking at simple slopes and simple intercepts. And as you can see, the intercepts are different, which means that we have a significant main effect for our moderator, but we do not have a significant difference in slopes, which means that we have a non-significant interaction. And this was also modeled in the y variable with the parameters you see below. So we knew that there would be no significant change in slopes. And again, in our second moderation model, I wanted to run the diagnostics, and we can see by looking at our distribution of our residuals that they look that our assumptions are relatively blue. And finally, I'm going to move on to moderation model 3 and see if we can change this, the relationships between our variables one last time. So in moderation model 3, we actually fail to reject the null hypothesis for x1, but we have a significant main effect for our moderator. So when we include the interaction term, there's no change in the amount of variance explained because we do not have that significant interaction effect, but we have this significant moderator. So let's see what this might look like in a graph. So as we know from going through the previous slides, we will see a significant main effect for our moderator because there's a change in intercept. However, we will see that there's no significant change in slopes, which helps us to easily see that there's no significant interaction for the moderator. And as you can see here, I've modeled y similarly to how I've modeled y in the previous models. And finally, I'll look at the diagnostics for our third moderation model to check these. And by looking at our residuals and our leverage plots and distributions, we can see that our diagnostics look pretty blue. So just to finally cover some implications of moderation, we always want to consider power. And as we know, power is a function of sample size, effect size, and p-value. But here we are mostly worried about effect size. So given the hierarchical testing of effects, and that just means that we will always test the main effects before our interaction effects, this would cause our effect sizes to be attenuated because there's essentially less variance of y remaining to designate to that moderated effect. And another thing we must consider is measurement error. So this is always a consideration in regression equations, but because measurement error will increase standard error, but in an interaction term, we will have compounded effects of unreliability because the term is multiplicative, and this might cause our effects to be underpowered. And then finally, as I mentioned before, we have multicollinearity issues, but this is why we use centering to help deal with this. And so moving on to mediation, I wanted to first compare moderation and mediation, so we had a clear distinction between the two, and Barron and Kenny make the point that we really can't use the terms moderation and mediation interchangeably, especially given their differences in relation to causality, and by that I mean their causal relationships with X. So going back to the general linear model, our main goals are to predict and describe, and so what we're dealing with in mediation is incomplete prediction models. And so the difference between mediation and moderation mostly has to do with the causal relationship with X. So a mediator is a temporal causal pathway where we're using the most proximal predictor. However, a moderator just influences the relationship between X and Y and is not temporally bound, and there's no causal relationship with X, as in mediation where the mediator comes about as a result of X. So both can have a direct effect, but they differ in that causal relationship with X. So to look more explicitly at the mediation model, we can see clearly that a mediator provides an alternative indirect causal pathway, and the antecedent acts on a consequence through a mediator. And that just means that the X to Y relationship is contingent on pathways A and B. And so going through the next slides, I'm going to use the Barron and Kenny mediation model, which outlines 4 steps. And in Kenny's 2018 overview, he goes through the 4 steps, and we will test first the direct pathway of C, which is direct relationship between X and Y. Then we will test the relationship between X and the mediator, so pathway A. And then finally, we will test the pathways B and C prime to test the effect of the mediator and the antecedent on the outcome variable together. And so in this first mediation model, I'm going to first test the direct path, and in Kenny's 2018 overview, he notes that this first step, establishing a significant direct relationship between X and Y, is up for debate, but we're going to go through these 4 steps anyways, and in this model, I did want to run some diagnostics, and they look relatively blue. So moving on to text the next 2 pathways, we can see that X is a predictor of the mediator, significant at the 0.05 level. And by testing X and the mediator both as predictors of Y, we can see that path B is significant, but that X is no longer a significant predictor of Y on its own. And according to Kenny's 2018 article, when the C prime pathway does not remain significant, then we fail to rule out full mediation. So let's do some bootstrapping to see if we can get a little more confidence in these outcomes. So bootstrapping is a resampling procedure, and here we've resampled 1,000 times. And importantly, according to Preacher and Hayes, bootstrapping really provides us one of the most powerful and reasonable methods to get these confidence intervals for indirect effects under the majority of conditions. And another important point that they bring up is that bootstrapping does not impose the assumption of normality on this sampling distribution. Rather, random sampling will give us symmetrical errors around our estimates. And so this allows us to conduct analyses even when we may have low power. And essentially, bootstrapping increases our confidence in our parameter estimates by increasing our replication, and that will increase our reliability. So the 2 important things we want to look at here are ACME and ADE. So ACME, the average causal mediation effect, represents this indirect effect, so pathways A and B. And we can see that 0 is not present in our confidence interval, and we have reached significance at the 0.05 level. And so that means that we fail to rule out mediation, and we also don't see that direct effect. So in this data modeling for this first model, Y was a function of the mediator, and the mediator was a function of X, but Y was not directly a function of X. Rather, it was just a function of X through the mediator. So let's see what happens when we test a new model. So here we'll test another mediation model, and then we'll vary the way our data is constructed to see how this might affect our outcomes. So following the same pathway testing logic, first we've established a significant direct effect, and our assumptions for this model look blue. And then moving on, we've also established X as a significant predictor of the mediator, treating the mediator as our outcome variable. And then in the final regression model, we can see that X remains a significant predictor of Y, but the mediator is no longer a significant predictor of Y. Therefore, we do not fail to rule out mediation. So B is not significant at the 0.05 level. So to get more confidence in these estimates, we conducted bootstrapping again to add power to our tests. And we can see that in this scenario, there is a significant direct effect, but there is not a non-significant indirect effect. So the causal pathway of A and B is not significant, and that we see that in the non-significance of that particular B pathway. So just to conclude with some implications of mediation, mediation really represents an alternative causal relationship in which X precedes the mediator in its influence on Y. And if we have an incomplete prediction model, we're really going to have attenuation of our relationships and poor prediction in the future, which are really the main goals of the GLM. And we must use the most proximal predictor in the causal pathway in order to best explain variance in Y.